Hi everyone, today we are going to learn how to solve linear systems by graphing. Now there is some vocabulary that we need to go over first because systems are a new concept for us. So a system of equations is a set of two or more equations with the same variables. So now instead of just having a single equation, we're going to be working with two. So we're going to do systems of two equations. And notice that both of these equations have the variables x and y. So we're going to be looking for a solution to the system. So a solution to a system of equations is an ordered pair, so an xy coordinate, that works for both equations. That's a really important thing here. Now we don't only need to find a value that works for one, we have to find a set of values that work for both equations. And then another word that we're going to be using today is the word intersection. So an intersection is where things cross each other. So there are three different ways that we're going to learn how to solve systems of equations. The first one is graphing, and that's the method we're going to learn today. And then there's also what's called the substitution method and the elimination method, which we'll learn later on this unit. So solving by graphing is pretty straightforward as long as you remember how to graph a linear equation. So we graph both lines on the same xy axis. That's an important part. We're going to graph both lines on the same xy axis. Then we're going to find the point of intersection. So remember, an intersection is where things cross. So we're going to figure out where your lines cross, and we're going to circle it. And then we're going to determine what that point is, and we're going to write our answer as an ordered pair. So our answer should always be written as an ordered pair, an xy coordinate. So really, if you know how to graph a linear equation, which you do, you should be able to solve by graphing. Okay, so let's look at this first example. So here's our system. We have y equals 2x plus 5, and we have y equals negative 4x minus 1. So I'm going to start by graphing this first line, y equals 2x plus 5. So remember, we start with the y-intercept. So our y-intercept is going to be 0, 5. So I'm going to plot that point right here. And then our slope in this case is 2 over 1, which tells us to go up to right 1, which goes off our graph, or I can move backwards. I can go down to left 1. So I could go up to right 1 or down to left 1, and I can repeat that same slope pattern a few times until I have a nice accurate graph. Okay, so that's the graph of the first equation. Now let's graph the second equation. So we have y equals negative 4x minus 1. So this one has a y-intercept of 0, negative 1. So we're going to start right here. And the slope is negative 4 over 1. So that means I can go down 4, right 1. Or I can go backwards. I can go up 4, left 1. And then I'm going to connect my dots. So that red line is the graph of this second equation. So now, according to our steps, we look at the graph and we find, or the two graphs, and we find the point of intersection, and I'm going to circle it. So this is the point where both of our graphs touch. So since both of our graphs are going through this point, I know that this coordinate actually works for both equations. So my last step here is just to determine what is this coordinate. So I see this coordinate is negative 1, 3. So our final answer should be written as an ordered pair. Negative 1, 3 is our answer. So what this means is this x and y value actually work for both the blue and the red equation. Okay, go ahead and pause the video and see if you can give these two examples a try. Okay, let's go ahead and check our answers. So this first equation is graphed right here. My y-intercept is 0, negative 1, and my slope is positive 1 over 1. My red equation is graphed right here. My y-intercept is 3, and my slope is -1, so I went down 1, right 1. And I can see they intersect right here. This coordinate is 2, 1, so that's my answer. This one, I made a larger graph. My y-intercept for this graph is way up here. It actually went off my graph at 0, 14, and my slope was -5, so I went down 5, right 1, down 5, right 1, and I did that a few times. For my red graph, this y-intercept is at 0, -10, and the slope is 1 over 1, so I followed that slope until they intersected, and I can see that they intersected at the coordinate 4, -6. All right, so you might also see some equations, a system of equations, where they are not written in slope-intercept form. So of course, for us to graph these, we want to rewrite them in slope-intercept form. So let's start with this first equation, x plus y is equal to 8. So we're going to rewrite that in y equals mx plus b form. So I'm going to subtract x from each side, and we have y equals -x plus 8. So this line has a y-intercept at 0, 8, and it has a slope of -1. So I go down 1, right 1, down 1, right 1, and I can continue that pattern also going to the left, and then I can connect my dots. And then my second equation, we also need to rewrite that. So let's rewrite that equation, x plus 3y equals 12. So I'm going to subtract x from each side, -x plus 12, and I'm going to divide every term by 3. So that leaves us with y equals -1 over 3x plus 4. So remember here, -x over 3 is just -1x over 3, and we can rewrite it like this so it's clear to see what the slope is. So here, this graph has a y-intercept of 4. And it has a slope of -1 over 3. So I go down 1, right 3, down 1, right 3, down 1, right 3. So when I connect these dots, I can see that I do have a point of intersection right here, and that point of intersection is at 6, 2. So this is the solution to our systems of equations. So just remember, you can still solve by graphing even if your equations look like this. You just need to take a moment and rewrite them in slope-intercept form. Okay, go ahead and pause the video and see if you can give these two problems a try. You will need to rewrite this in slope-intercept form, and you'll need to rewrite both of these in slope-intercept form. Okay, go ahead and check your answers here. So you can see this blue equation is graphed right here. My y-intercept is 0, -7. My slope is -4 over 1. So you can go down 4, right 1, or up 4, left 1. Here I rewrote the equation to become y equals -x plus 2. Y-intercept is 2, and the slope is -1 over 1. And if I work my way backwards, I see the point of intersection is at -3, 5. For this second example, you have to rewrite both equations. So you should have gotten y equals x minus 5. So remember here we have to divide everything by -1. And here we should get y equals 3x minus 1. So we just have to add 3x to both sides. When you graph those two equations, they intersect over here. It did go a little bit off our graph, but they should intersect at -2, -7. All right, that is all for today's video. Thank you so much for watching.